If you start working on robotics, the first and interesting project is line follower robot. So what basically does a line follower robot do is it basically follows a line or specific path that it is intended to travel, right? So for a line follower robot, we basically require moment, and then it follows a line, and when it has to move, there must be some mechanical movement that should happen, right? That is done by the motors. Okay, so motors are a must for the movement, and you have to drive these motors electrically such that the electrical energy is converted into the mechanical energy. So you need a controller to drive a motor. What do we mean by controller is basically a microcontroller kind of thing that is required, or microcontroller or a processor, FPGA, whatever. And one important point is motors work at high voltages like 12 volts, 24 volts, 48 volts. Now, to drive those motors, microcontrollers, which generally operate at 3.3 or 1.8 or 5 volts, cannot drive. They don't have the drive strength to control the motors. So, for that, we need to have an interface in between, which are called the motor controllers. So, the controller drives the motor controller chips, and motor controllers further control the motors. So that's how the sequence will be. So if you see, this is how the sequence looks like. So we have a controller, which is which could be a Raspberry Pi, Arduino, MSP432, STM32, whatever. And using the GPIO pins or the PWM pins of these controllers, we drive a motor controller, and motor controller further controls the DC motors, which move, which provide the movement. Okay, so if we look at the motors, basically motors, we are talking about DC motors. So DC motors require uh, a PWM based signals for them to move and provide the ultimate mechanical moment. So this movement can be slow, fast, or medium, right? So the speed need to be controlled by the user. So it's not like you just give it just races ahead, right? We have to have a controlled speed. So for controlling that speed, one of the mechanism is PWM duty cycle. So using the duty cycle, we do by varying the duty cycle, we do control the speed of the motor. And then sometimes we might need a forward movement, we might need a backward movement, right? So based on the current that is passing through the motor, the direction of the current, we can control the direction of the movement. Okay, so we will see what all chips can be used here later. So ultimately, the thing is, motor control is required. For motor control, we require a motor controller, which is driven by the controller. Now, one of the common motor controller chips that are used in the market by hobbies or simple commercial applications is L298N. This is how it looks like. So if we see here, this is the motor controller chip, which is having a heat sink to it, screwed, um, and we have connectors, an onboard regulator. So onboard regulator to provide the power, whereas connectors to provide to have the external supply and motor interfacing. So if we see the actual pinout of this L298N motor controller, you can see there are four output pins: output 1, output 2, output 3, output 4. We can connect one motor to the output 1, output 2 pins, and another motor to output 3 and output 4. That means this is a dual motor driver or motor controller chipset. Okay. And then we can see we can provide, ultimately we require supply for operation, right? One supply is for the actual motor drive, and other supply is for the IO control. We can see this is the connector that is used, and we have enable pins for this motor driver 2980N, which actually has to be enabled for the output to pass to the motor. So we have two enable pins: enable A and enable B, and in 1, in 2, in 3, in 4 are the pins, PWM pins that come from the main controller. So to understand the entire scenario, we have a controller which controls the enable and in 1, in 2, in 3, in 4 pins, and ultimately the motor driver drives the motors on the two ends of this board that we see here. So, if we dig deeper into the L2980N, this is the block diagram of the chipset. So, if we see the block diagram of this chipset, we have two H bridges. This is the first H bridge and this is the second H bridge. So, we need H bridge configuration to drive a DC motor and to change basically its direction. So how it changes is, example, if you see here, if this transistor is on and if this transistor is on, the current flows from one side to the other, and if the opposite transistors, this transistor and this particular transistor are on and the other two are off, the current flows in reverse to the motor, which causes it to move in the opposite direction. Similarly, another H bridge. So, and then you can see here in 1, in 2, in 3, in 4, where we can control the PWM duty cycle to control the speed. And we have the power supplies, VSS, enable A, enable B, and we also have sense pins. So we will talk about the sensing, current sensing later. Okay. So overall, if you see, this is how a motor driver circuit looks like, where the microcontroller drives this motor driver, and motor driver further drives the DC motors. So these form the base of a simple line follower robot, and to have a list of boards that is required, we need a microcontroller evaluation board, we need two DC motors, we need a motor driver module or a board like this L29810, and ultimately batteries or whatever, or a DC power supply, because DC power supply cannot be given because the motor moves, right? So it has to operate on battery. So we need batteries to power this. So this is the overall structure. We will talk about these boards in the later videos. Thank you.